Okay, so yesterday we learned about the translation and the DSCP and all. Anyone any doubt? Like what is the translation? What is the DSCP? No. Okay, the first topic is NTP. NTP, Network Time Protocol. Network Time Network Time Protocol. Have you heard about the digital certificates and all, public infrastructure, digital certificate, why we are using and where we are using? Any idea? Public infrastructure, digital certificates, digital signatures. No. What the meaning of this lock? Secure. And you can see we have some certificates. If you want to access this website, we need some certificate. And maybe in college time, suppose currently my date is 19th March 2021. Okay, if I change to the 1980, then can I able to access this website google.com? Huh? If I change my date to the last like 1980, 1950 something, if I change, so can I access this google.com? Do you know what is a digital certificate? Digital certificate. Okay, two authentications and all we are using. If I so currently you can see that my date is 2021. If I change to the 1950, then that certificate is valid or not? It's not valid. Suppose you have an organizer. Basically, why we are using the network time protocol? In the real scenario, we are using the digital certificates. If you want to access any website, like you can see the google.com, so Google provide me one certificate, and that certificate I have to install my PC. Same like if you are working in some organizations, they have some website locally, and if you want to access that website, so you have to install some certificate. They will provide you. In the certificate, we have some time. Suppose if you have any time mismatch, so you can't able to access that websites. So suppose currently I have some PCs, like this is my environment. In this environment, I have some PC. This is my one local. This is my HTTPS server. This is my PCs. Different. I have some PC. So this is my PCs. My task is I want to access my HTTP server. This is my HTTPS server. So when you want to access this HTTPS server from your PC to this HTTPS server, you have to install some certificate. In the certificate, you have some your own public address, private address, that server's public address, like that you have some information. And also you have some time. If you have some time mismatch, so you can't access this website because of the time. Because in the like, if you are working in somewhere, so you have some time period. Like you have to come to the office at the 8 o'clock, and you have to leave from the office at the 2 o'clock. This is your time period. If you are coming after 2 o'clock, so they are not going to permit you to enter your office. So similarly, in the environment, we have some digital certificate. In that digital certificate, we have some timing. This certificate is valid from this time to this time. If my time is mismatched, so I can't access that website because there is a time mismatch. So for accessing this digital like HTTPS server, they give me one certificate. In the certificate, we have one time. 3/19/2021. This is my starting time, or you can say 15 is my starting time, and 15/2025. Like for the 4 years, it will valid. But suppose if I change my PC timing with 315, 9050, then it's invalid. So sometimes you will get your time mismatch, your system is outdated. Like this, you will get the error. In old version, like in the Windows 7, we'll get this kind of issue. So for resolving this kind of scenario, what you have to do? You have to change your time in your PC manually. So here in this scenario, suppose I have only 4 PC. So it's not a big task. I can do it manually. But suppose in your environment, you have a 50 PC, some devices, 10 devices in a different location. So it's very difficult to go to the each and every devices and change the time. So they introduce this NTP as a solution. Make one NTP server, like deploy one NTP server in your environment and configure convert this PC as a NTP client. If you want to any time, like a DSCP, if you want to IP address, please send the request to the server. Similarly in the PC, like for the time, if you want to time, just send the request to the NTP server and he will provide you time, exact time. If we are receiving the time from the server, so there is no time mismatch. So this is our concept, NTP, network client protocol. So in this, we need one server and the client. You have a public IP address, private IP address, time, validity, organization name, lots of things you have. Not a MAC address. Different things you have. Cisco packet tracer. Mainly in that certificate, you have organization name, your validity time from 2, then your own public IP address, not a private IP address, your own public IP address and some digital signatures and all you have in that certificate. So public key infrastructure. So now in this scenario, I'm going to take 2 routers. One as a server and the second one as a client. So assume this is my server and this is my client. First, we got reachability. So you can use any IP address, any network, doesn't matter. So config interface F0/0, then IP address 192.168.1.1.255.255.255.0, and change the host name as a client. Then the server CLI config interface F0/0, then IP address 192.168.1.255.255.255.0. The host name is server. So first check the reachability. Ping 192.168.1.1. So we have reachability. So now my task is I have to convert this router as a NTP server. And make this one as a client. So come to the server, config NTP master, and you have to select some NTP ACT number. It can be anything, 2. That's it. With this command, we can convert our router as an NTP server. And also, if you want, so you can define like I want to make an NTP server router. I want to convert this router as an NTP server, but I want to advertise my network with specific interface. Let me first receive the IP address, or do one thing. First, check the clock. 1 minute. Master. First, check the clock. So, clock 1993 something. In the client also. So, clock 1993. So now in the server, I'm going to change my time. Clock set, question mark, this time, and then this is your format. Like first is hour, minute, second, date, month, and year. Okay. Now check your clock. So clock. So time is updated. Come to the client. Again, check your time here. It's 1993. Now again come to the server. Again convert your server as an NTP server. NTP master UNI number. That's it. Now come to the client. The client again check your clock. Is that now I have to configure my NTP server IP address. Like in the DSCP, we are sending the broadcast because at the time we don't have any IP address. But here I have IP address, I have reachability. So I can tell my router if he wants to receive any time. So this is your NTP server. NTP server IP address 192.168.1.2. And sometime this process will take 2 minutes, 3 minutes, 5 minutes. It depends on the router. It's not synchronized. This one command, so NTP, so CSN. So you can see here, I configure this NTP server manually. Okay, configure this one, symbol. It's configured, but it's not a synchronized. Still, my system is receiving the IP address like time from the local time 127. Just wait some time. So in the reality, sometime if you have bad luck, so it take around 10 minutes, 15 minutes, and sometimes 30 minutes also. And this is a very important topic for the security lab. In the lab exam, CCNA lab exam, this is your very important topic. And people are getting failed due to this delay. But this is our simulation, so we can forward our time. Now come to the client and check. Now you can see here, previously it just configure this one, this symbol only we had. But now we have a star. Star means synchronize. Now again check your clock. Now it's updated. So like this we can receive the time from the NTP server.
What will be the output for show and association?
Star. It doesn't matter. Like you can see, it's synchronized. We configured this one previously, but now it's synchronized. It means it's going to receive the IP address from here. There's one more command. So NTP status. So in the real time, you will get here as a 3. Because in the NTP server, we set X number as a 2. So in a real time, you will get here as a number of 3. But in this, you don't know why it's not receiving. But clock is synchronized from this. This is your NTP server. Okay. It's just a reference. Like if I don't have any configure NTP server, then it's going to refer is on clock. Your on clock, like 1993, that one. But here I configured and he synced. Here is synchronized, so I have to receive the time from here. See, 3. The time. Second is again they are exchanging some time. They have to exchange. They have to mention make that neighborships. In each and every scenario, if you are receiving something from your server, so you have to make a connectivity. That's why they are exchanging some message and all. And we don't have any delay and all, nothing we have. In this also, sometime, like if I'm talking about the CCI security lab, so NTP is not like one line of command. Like here what we did, we have one server, and in the server we configured our NTP. Simply I fired NTP master and I gave that number. And in the client I gave like NTP server and the IP address 191.168.1.2. That's it. In this scenario, I gave only one more line command. But in the CCI security or in the enterprise, you have authentication, then encryption, then also we have time. Which time I have to synchronize, which time I have to send my request after configuring this one 5 minutes, 10 minutes, like this way, all these things. So mainly we are using authentication and the encryption in the NTP. Like you are a client and you have one server. When you are sending the request to the server, so server is asking like, just give me your password, like authenticate yourself. So in this scenario, we can use authentication. Encryption when you are receiving any packet, so please encrypt your packet and then send me. Otherwise, someone can show your packets, what kind of data you are sending, and in that packet, maybe our packet is in the plain text, so they can check, okay, what is the time, and they can set manually. These things we have. So normally, this is your NTP. Just for the time synchronization, we are using our NTP server. What location locally doesn't matter. Just we need a reachability with our server. This is your NTP server.
What about the third one? Time?
I'm like after 5 saying like I configure my NTP client right now, but I have to send request after some time, not now. Like in the access SCL also we have, like I want to execute this access list after like at 12 o'clock, 3 o'clock, these things. Yeah. This we can do it. So this is your NTP server. That's it. And the NTP we have these things only. It's just like how to yeah. For the CCNA is just in the CCI also you will get, that's it. Just they will introduce like how to encrypt your packet or how to authenticate these things. Only these 2 or 3 things they will give you in the CCI. Because you can learn by yourself this NTP. That's why they are not including. Just they say, okay, just authenticate. Like for the authentication, we have to establish like we have to give preset key, or we can use like triple S server, or which encryption method we have to use. These things we have to apply. Only 2 lines or 3 lines of command. But the concept is remains same. Why we are using NTP server? For saving the time. For time synchronization, we are using NTP server. That's it. Okay. Any doubt? Online guys, any doubt?
No, sir.
No, sir.
This one's clear. So now I have one question. NTP is done. Have you heard about the redundancy? What is the redundancy? Experience guys. Redundancy. That just normal word. Online guys, what the meaning of redundancy?
Redundancy means next available path, means 2 paths to reach one destination.
Redundancy. If I have like you have to reach to the airport, like if you have 2 paths, if one goes down, then you can prefer second one.
Second one.
Redundancy is a backup and all redundancy. Simple word. So in a real time where we are using this redundancy concept. Suppose you have one switch, you have one area, like this is your environment. This is your switch. You have some PC. Like this, you have some PC. This is your router and device. And your end device is connected with the ISP. This is your ISP. PC1, PC2, and the PC3. This is your switch, router, and the ISP. ISP. Now you have IP addresses, you already configured your routing protocol, you have a translation enable. It means you have a reachability from your PC to the ISP. It's working fine. But suppose your link goes down, then what? ISP down. Then we need one more backup, like in a real time, we have to purchase two different ISPs and all. Like 2 days ago, my internet goes down. So in the lab also internet goes down, but in the second floor, it's there. So like this, we can purchase some two different ISPs internet. So I have one more ISP here, ISP2. So if I suppose my ISP1 goes down, then I can forward my data with the ISP2. So this concept, it's called a ISP level redundancy. We can take a two ISP connection and we have to send our data via ISP1. Okay, what's the meaning of the load balancing? Load balance. If you are getting lots of load to the router one, so we have to balance it. It means here we have two parts to get the internet. So some packet I can forward via this way, some packet I can forward via this way. These are two concepts: load balancing and the load sharing. Balancing, like no, but something we can learn, like some extra things we have to learn, like what the load balancing and the load sharing. Yeah, in the CCNA we'll get. This is our like, Rakesh, what the difference between the load balancing and the load sharing? Any idea?
Load balancing, sharing equally data on both both direction. Load sharing, no. Load sharing. No. Sharing means I can manually define which traffic have to go from which path, right? Sharing means
Like there is one concept, load balancing and the load sharing. It depend on your load balancing. It depend on your bandwidth. Okay, bandwidth is a sense. Suppose you have a 20 Mbps speed and the 10 Mbps speed. You are receiving some data here, balancing. So in one packet we have like it need 10 Mbps speed something. So first packet is going to forward here. Second also is going to forward here. Third is going to forward in this way. Then again, 4, 5th, 6th. So it's a load balancing. We are balancing our load. Okay.
okay.
Then load sharing. One data I am sending here, one data I am sharing here. Equally, I am sharing my data.
Load sharing.
Yeah, we are using both link, but this is a concept, balancing and the sharing. According to your link speed, we are balance our data and sharing, like some data I want to share from the here manually, some data I want to share from the here, some data I want to share from there, not sharing. So now in this concept like this, your ISP level redundancy. If my ISP1 goes down, then we have one backup link. We can forward our data via second. Okay. But suppose your router one goes down, then what? Hardware failure, power failure, link goes down. If your router one goes down, then what? We have internet connection. Let it know. So in this scenario, what you can do? We need one more router. We can deploy one more router here for the backup purpose. So this is your hardware level redundancy. This is your R2. And suppose in this scenario, like we have two routers, so why should I like connect both two ISP with the one router only? I can connect ISP1 with the router 1, ISP2 with the router 2. Okay, like this. So remove this one. This is your ISP. And connected. So that one is the ISP1 and ISP2. So suppose my one router goes down, then I can forward my packet from the second one. Agree? Sure. We need a backup. Okay. So if I want to say I want to get the internet connection. Okay. So just tell me which path I have to prefer. From the R1 or R2? Both are R1. This one is R2. So which path we have to select? From the R1 and R2. I want to get the internet connection. Okay. So which router I have to get the internet connectivity, from the router 1 or router 2? Okay, suppose my router 1 is not, router 2 is not there. We have only router 1. Okay. It's a backup purpose. When this one goes down, then we have to forward packet via this one. Okay. Just 1 minute. Let's change here like 11. Okay. This is my one network, inside network. So here I'm using one network 192.168.1.0. Okay. My PC1 IP address is .1. My PC2 IP address is .2. PC3 is .3. This one I can give .10 and the .11. Okay. .11. Okay. Now, this is your end device. So in the end device, if you want to reach from one network to the different network, what kind of data we need?
Gateway.
Default gateway. In this scenario, who is my default gateway? In the PC, you can assign only one IP address, I guess.
192.
You can see here, if I'm taking end device. My laptop also finished. Desktop IP configuration. You can see I have only one option, like I can assign only one default gateway. So just tell me, who's your default gateway? .10 and the .11. So who's your default gateway? Why not .11? If I suppose manually I came here.
It all depends on the gateway configured in pieces.
Huh?
It all depends on the gateway configured in pieces.
Both are working fine in your environment.
Which is the one?
Which is the okay, which one?
10 are-
Okay, suppose I configure here 10. It means your traffic going via this way. So if this goes down, then again you get
configure the same.
again I have to manually do. Okay, suppose here yesterday, 2 days ago, my internet is not working. So I'm not going to change my default gateway. I thought my ISP goes down. Maybe ISP goes down. How do I know my router goes down? How do you know? Is a networking partner, you are account manager, like you are an employee of the account department. So you are not familiar with these networking things. If your internet goes down, so you are setting ideal, okay, maybe my internet goes down after 5 minutes, 10 minutes, we'll get the reachability. But in the reality, your router goes down. So in the networking department, they know, okay, so they can manually change their default gateway. Okay. But how we can,
PC2 we have to configure the different.
in which?
PC2.
In the PC. .11. This is your PC. You need an internet connection from in the PC one. This is your PC, this is my PC, and this is someone else's PC. Okay. In this PC, I need an internet connection. Okay, and you define here .10 as a default gateway. It means your packet going via this one from the R1. Your device goes down.
Then again we have to change gateway IP.
But suppose I guess you are the employee of the account manager, account department. So how do you know, like in which scenario you have to change your default gateway? Okay. Yeah, in the DSCP, already we received the DSCP. Already you receive one IP address from the DSCP. So that IP address is reserved for 24 hours. So manually you have to send again DSCP request. But how do you know in which scenario we have to send our DSCP request? And this is my router. Maybe in my environment, I can deploy one different DSCP server. So whenever I'm sending my request, so it will reach to the DSCP server and it will be giving me the IP address. So in this scenario, we have one concept, FHRP, first hop redundancy protocol.
FHRP.
FHRP. FHRP. First, it is first hop redundancy protocol. Let me check before. FHRP. Yeah, first hop redundancy protocol. Okay. In the FHRP, we have three different protocols: HSRP, VRRP, and the GLBP. One more thing, these are just a theory topic. Okay. FHRP, in this FHRP, we have three protocols: SHRP, VRRP, and the GLBP. Now, first, just tell me the answer. Now, like in this scenario, what I have to do? I need an internet connection. Just give me the answer. Then we can discuss about this one. So in this scenario, we have to create one virtual interface, one virtual gateway, with the IP address anything .100, and this IP address I have to define in my PC. Okay, in my PC. So how can we create the virtual gateway? With the help of these protocols. Okay. So with the HSRP, VRRP, and the GLBP, let's talk about the first two options, SHRP and the VRRP. These two, HSRP and the VRRP, they are working on the active standby method. What the meaning of active standby? In this scenario, we have two routers. So one router is in an active mode, and the second one is a standby mode. It's there, but we have to forward all the packets via this one. It's there, but it's not in working state. When this router goes down, then it will be consumed. Right? So you can say this is your active and this is your standby. So we have to forward our all packets from the active nodes. And this one is a standby, is ideal. When your active node goes down, then it will become active. But how this router now, like my router 1 goes down? This is your active and this is your standby. So how your router 11 knows like my router 1 goes down? Any idea? Okay. For building your neighborship, okay, what we are doing in the OSPF? We are exchanging some hello messages and all. Remember the thing, hello message, hello time, or and all. We are exchanging our hello messages. So in this scenario also, in HSRP, VRRP, and the GLBP, they are exchanging some hello messages. With that hello message, they are saying, okay, I am working fine, and I am active mode. I have to forward all the messages. So suppose router is in active mode. This R11 is a standby mode, and they are exchanging some messages, hello messages, in each and every 3 seconds in the HSRP. There is some timing. So they are exchanging some messages. If my standby is not receiving any message, hello message from the R1, so after 3 seconds, it will recognize, okay, my active mode goes down, so I have to become active. I'm going to send some request to the switch. I'm now active. Please forward the all packets from me. Okay. He's going to send some message to the switch. Switch is going to update his MAC table. In the MAC table, our default gateway is .100 and MAC address of this router. So your packet is going to forward via this way. Clear? So for this scenario, we have 3 protocols: FHRP, like SHRP, VRRP, and the GLP. It's 1 minute. I have one document. I have one lab, but I'll just show you how this packet is working, like how your packet is going from via one network to the another network. Just a theory. What happened, guys? You are feeling sleepy in this in the chill environment. Huh? Okay. So this is our 3 protocol: HSRP, VRRP, and the GLBP. So HSRP and the GLBP is a Cisco proprietary. Cisco introduced these protocols, but this one is open standard, IEEE standard. And same like OSPF, REAP, and ARGRP, if you have to exchange some routing information in the hello messages, so we have one multicast IP address. So in this also we have one multicast IP addresses. Okay. And now you can see the hello messages. 3 seconds, hold down 10 seconds. If after each and every 3 seconds, we have to exchange our hello message. But if we are not receiving any hello message within a 10 second, then that router goes down and I'll become a active mode. And this also we have some advertisement and then -1, some calculation in this we have. And in the GLBP also same, 3 and 10. But there is a one advantage is with this GLBP. Your GLBP is supporting load balancing. No such thing like what is the cost of one router? If you are purchasing any new device, so what's the cost? Normal router is costing you around 5,000, 10,000. Normal router, TP-Link and all. This is your router, Cisco router. So maybe around 50, 60K or more than that lakhs and all. So it's like a good solution, like for I can make active and understand my method. Like I invest some money on this router, I purchase some ISP, I connect with this router, and this node and my internet connection is become idle. I'm not using that things. I'm not using that resources. You can say it's a wastage of my money. So I have to use that resources. So for using these resources, we have one concept, load balancing. We have to share some data via this way, and we have to share some data via this way. So like this, I can use all the resources. Suppose your router one goes down, then we have to forward all the data via this way. It's okay, but I'm not going to make this one is a active and this one is a standby. I want to use all the resources. So that's why we have to use load balancing. Active mode. Active mode. I have to send some data via this way and some data via this way. So in the GLBP, we have this feature. In the GLBP, we have a load balancing, but not in the HSRP and the VRRP. We don't have. Okay. Now, I'll give you one example. Just 1 minute. So IP interface, please. 68. So now this is my ISP. Okay, this is my ISP. And the ISP, I have one loopback. That's my router. This ISP, I have one loopback. So IP interface brief. So IP interface brief. 1.1.1.1. Now I want to reach this network from my PC. Before it, just come to the router one, just move your mouse, and you can check here the IP address .10.10. Like F0 by 1 IP address is .10. And here F0 by 1 IP address is also .20, 1.10 and 1.20. Now come to the laptop 0. What's the default gateway? .100. Different. It's not belongs to router 1 or neither router 2. But still, if I'm trying to reach to my that 1.1.1 network, is resolving the MAC addresses and all. Now we have reachability. Okay. We have reachability. TRS, CRT. Trace route. We have. Now capture the packet. Which path is preferring? See, trace route. Yeah, we have. So it's sending the packet first 1.20. It means your packet is reaching to the router 2. So it means this router 2 is my active one. Suppose your router goes down. Hardware level redundancy. So now it's taking some time, like around 10 seconds. It's taking around 10 seconds for sending your packet from a second way, because it's going to say check your timer. Like I configured here HSRP, this one. So it's going to hold your data, like it's waiting to the 10 seconds. So after the 10 seconds, we will get the reachability. And try to reach ping. Now we have reachability. Now again, trace route. So now you can see my packet is going via 1.10. I didn't change, I didn't do any kind of configuration in my devices. Automatically it's going to redirect your path. This is your hardware level redundancy, HSRP. This is your configuration, like just we have to fire 2 lines of commands. Standby 1 and the standby primitive. With the help of the standby 1 IP, when you are defining this IP, so it's consuming like this my virtual gateway. Virtual gateway. In the second line, you can see the standby 1 primitive. It means previously this router 2 is my active one. So when it comes up, so again it will make like I am previously I was active. So again I need my power back, because primitive it means like I am active, I goes down. So my standby become active. So when I come when my router comes up again, so I'll become again active. So you have to forward all the data through me. These are primitive means. So just 2 lines of code. The 2 lines of code, you can achieve this goal. This one, this 2 lines of code. With these 2 lines of code, you can create your virtual gateway. That's it. This is your 2 lines of code. Standby 1, IP 192.168.1.100. Both in the both router, you have to fire these things. Standby 1 IP, your virtual gateway, primitive. Then they are going to exchange some messages. In that messages, we have some priorities and all. With that help of the election process, they will elect who will become active and who will become a standby. And we have to forward all the traffic via active one. Okay, this is your FHRP and one of the examples. Yeah. So that's why I'll tell you, like when you are configuring these things, then they are exchanging some hello messages. And the hello messages, you have some priorities and all. We have some priority. Election process is going to check the router highest. Active router first is the highest priority, then higher IP address. By default, your priority is 1. So again, it's going to check the higher IP address. So in this scenario, this router 2 has a higher IP address. You can see here 1.20, like 1.20. That's why. And here. And also, you can see, okay, not that one. You can see here, first one is a 100.10, and here we have a 200. So this is my higher IP address. That's why router 2 will become active, and this one become a standby. We need a reachability from here to here. Okay, we need a reachability. Then we have to configure, like in this router, we have to fire some commands, like 2 things. Suppose I configure here static route. So in the static route, I want to tell my router, if you want to reach 192 network. Okay, what's the commands of the static route?
IP
Route, destination network, then subnet mask, and the exit interface or the next hop. So in this scenario, like my next hop is like my network is 192 network. Will become my next hop. Router 1 or router 2? will become my
No.
next hop. Will become my next hop.
Router
and
one.
router two, both. Because if I say my router one is my next hop, my router one goes down, then what? What is my point? So in this scenario, we can do one thing. Do you know how to change the priority?
Yes.
ID value in the static. Do
Yes.
some practice on the statics and all. So run. You can see here, I defined my two default gateway, two default route. But here I change my ID value. So I said, okay, that's why my router is getting some. So you can see, first I have to prefer .2, then I have to prefer .3. It means I configure two routes, but I am checking my routing table. So IP route, I have only one information, static one, F0 by 0. F0 by 0. It means F0 by 0 R1. This one is goes down. Then you can see previously it was a F0 by 0, but now F0 by 1. Now it's going to forward your packet from second line via second link. So we have to create multiple statically like a static route or the default route. In this scenario, I use default route. Clear? And we have to
Yes.
assign the IP address. We have to create some static like static route. And in this, nothing. I just configured must one. And they are exchanging like speaking, standby, active, but they are exchanging some hello message, and with that hello message, they will recognize who will become active and who will become a standby. So run. In this, I didn't configure anything extra. This my IP address is F0 by 0, then F0 by 1. On the F0 by 1, just we have to fire these two lines of code. And I use IP route default route because this is my edge device. This is my edge device and I have to reach to the internet. So we have to configure our default route. So just I configure here default route. That's it. Clear? Now again, test out. Yeah, it will work. It will work when you are configuring your dynamic routing protocol. But in the dynamic protocol, we have some disadvantage. Like if I make neighbor of this router, like router one is my neighbor. So suppose if I configure OSPF, so we have a 10 and 40. Hello timer is 10. Your hold on timer is 40 seconds. So it's going to wait some time. Like when my router goes down, or I don't have any reachability, then it's going to wait some time for, it's going to wait like I have to receive some message, I have to receive some route, I have to receive some route for the 40 seconds. If I'm not receiving any hello packet, if I'm not receiving any hello packets, then this route goes down. So we have to wait till that time. When my dead timer goes down, it means we have to remove that network information from our routing table. Then it's going to forward your packet via this way. It's going to wait 40 seconds. That's why I configure here default. You can use static also, default also, and the dynamic also. But in the dynamic, you will get some delay anyway. But in the static and the default, your neighbor goes down, remove that link, like remove that statement, use the second one. Clear? So this is your FHRP.
So 1.100 is
Virtual router.
virtual router.
You can see here. I create virtual router with this command.
So in both router you have configured the same statement.
Yes, same statement. You can see here in the router one also. There's power on this one. Let's fast forward. Come to the CLI. Enable SOAR. You can see same command. Same.
And we have to configure this on the interface.
on the interface, like the F0 by 1. F0 by 1 is connected to my inside. So we have to
Okay,
configure the commands on our inside zone.
inside.
Okay. Clear? Done? So this is your FHR.
Sir, one more question.
Yeah.
This third router you have configured with 1.1.1, right?
Third router is your top one.
This is loopback interface, right?
Yeah, I created one loopback interface.
And we have two paths to reach that
Yes,
router.
we have two paths to reach to our destination.
You configure two default route in the same router.
Yes, in the
which
same
you-
router, but with the different ID values.
Okay, in ISP switch default. Okay, ISP router.
The ISP router.
Oh, okay, okay.
When you are asking the question, then you can get the exact idea. If I'm repeating 10 times, still you are not getting. Okay. Now, final. Okay. So this is your FHRP. Clear? Finally done.
Sir, sorry. One more. Like this, here you noted in that chat. Sorry, in this configuration, you have mentioned the both router configuration. Can you mention here the same in ISP? What is the configuration in ISP router? So that will help to understand more.
In the ISP, I just created only this route. That's it. No extra command. Only this two lines.
Okay.
Nothing else. Just I configure my static route. Just send your packet via this way. If this route is not available, then forward your packet via second way. That's it.
Interface IP also there, na?
Yeah.
So that is connected through outside interface of that R1 and R2, right?
Yeah. This one. F0 by 0 and F0 by 1. This ID value is 2 and this one is ID value 3. So first is going to prefer this one, then is going to prefer this one.
Okay, sir. Thank you. Got it.
Okay.
Yes.
So this is your FHRP. So your routing concept is done. Router is done. Now we have a switch. Okay, we have a switch. So on the Tuesday we'll go in the lab, not today. So today we'll just discuss about this some switch. What is a switch and all. It's just a 9 o'clock, so we have to spend some time. Huh? In the automation. So just tell me, like our routing is done now. Our main, like next module, you can say switching. Okay. So this is your switch. So just tell me, your switch is working on the which layer? Layer 2. It's a dumb device or intelligent? On which basis you can say it's intelligence? Okay, what's the parameter? So we have a MAC address, MAC table. We have MAC table. Then what's the next? Yeah. How many broadcast domain we have? One broadcast domain. And the collision? Per port collision. Per port, you know, in the like in the Gujarati, there is a one per port. It's a bubble. Per port. Okay. Anything else we have? Okay. So now by default we have one broadcast domain. Can we divide our one broadcast domain into multiple? I said by default is a one. By default. By default. Because by default we have one broadcast domain. Can you divide our one broadcast domain into the multiple parts? Like in the IP address, we have class A, B, C. By default, we have some classes. With the help of the subnet mask, CRDR value, we can divide our one network into the multiple parts. Similarly, in the switch, we have VLAN information. VLAN, virtual local area network, VLAN. So by default, in your switch, you have a VLAN 1. Your all ports belongs to VLAN 1. That's why this is your one broadcast domain. If I create one more VLAN, VLAN 10, and I can assign some interface on this VLAN. Like this is your switch. By default, we have a VLAN 1. Bye. Guys, just 1 minute. Don't know what happened with my mouse. Now, okay, leave it, my mouse. Okay. But why? But why? But why is leaving? Just 1 minute. Just 1 minute, guys. Yeah, here is working fine. In the notepad, I am getting some issue. Yeah, in the notepad, I am getting some issue. Yeah. Okay. Yeah, okay, so guys, so by default, we have VLAN 1 in your switch. Okay, and this is your one broadcast domain. Because all the ports are belongs to VLAN 1. It means you have one broadcast domain. This your VLAN 1 is a one broadcast domain. If I divide my VLAN, like router as a two parts, like VLAN 1 and the VLAN 2. It means now we have two VLANs. It means this is my one broadcast domain, this is my second broadcast domain. So now just come here. Take a switch. Now we have to do some configuration in a switch. Finally. Switch. Take some PC. 3, 4, 5, 6. Okay. So this is your topology. And the old connection. Laptop 1 to the switch, 2 to switch, 3 to switch. So this is your topology. And here I'm using 192.168.1.0/24. And the laptop 1 IP address is .1, laptop 2 is .2. Like this, we have IP address .3, .4, .5, .6, like that. Okay. So just quickly, I'm going to configure my IP address. Or configure manually first. 192.168.9.1. 255.255.255.0. It's very headache. Leave it. .192.168.1.1. In this scenario, no need of the gateway. 192.168.1.2. 192.168.1.3. 192.168.1.4. 2.168.1.5 and the last 1.6. Now just tell me, do we have a reachability from the PC1 to the PC6? 192, 168, 1.6. Do we have a reachability? Sure. Let's check the reachability. Ping 192.168.1.6. So yes, we have a reachability. Why? Because all the ports are belongs to VLAN 1. Come to the switch. There is a one command. Enable. And this also we have is the mode enable mode configuration mode. If you want to do any kind of configuration, configure. Command is so VLAN brief. So VLAN brief. So you can see here default, by default, we have VLAN 1. Name is a default, status is active, and the all ports are belongs to VLAN 1. That's why we are saying by default we have only one broadcast domain. And my all ports are belongs to VLAN 1. So my task is I want to divide my one broadcast domain into the multiple broadcast domain. So assume like this is a VLAN 1 and this is my VLAN 10. Okay. Come to the switch. We have a VLAN 10 created. The VLAN 10 is created. Like say, you can check here. So VLAN 10 is there. Okay. Now just tell me, do we have a reachability from laptop 1 to laptop 6? Do we have? Sure. Online guys, just tell me, do we have a reachability from the laptop 1 to laptop 6?
Yes, yes.
That's because I just created that VLAN. I didn't configure any interface in that VLAN. Yeah, still they belong to same network. You can see it. All ports I belongs to VLAN 1. So there's a two method to allocate that port into the specific VLAN. So like I can manually create my VLAN via this command. Okay, VLAN 10. Now I have to come to the specific interface. Interface F. We have to check the switch port.
4, 5, 6.
I guess here 4, 5, 6. Okay, so we have 4, 5, and the 6. So I can say interface F0 by 4. Then I can fire switch port mode. In the switch, we have two types of port: access port and the trunk port. Okay, trunk port we'll discuss on the Monday. Access ports, like access port means like this. You can say this is my end devices. So on the access point, we have to connect our end devices. So first I have to convert this port as a access. Switch port mode access. Okay. Then switch port mode switch port access VLAN 10. This is the one method. Like this, I can define my interface into that specific VLAN. Just check do so VLAN brief. Now you can see F0 by 4 belongs to VLAN 10. Clear? Now also we have two more ports, 5 and 6. So again, I have to come into the interface 5 and the interface 6. Suppose in your environment we have 10 ports and the 20 ports. So it's not good things like I have to come in each and every mode and I have to fire the same configuration. So I can use your range command. F0 by 4 to 6, 4, 5, 6. Enter. Now fire switch port mode access. Okay, instead of 2 lines of command, you can use also switch port access VLAN. Is a 1 line of command. Now again check do so VLAN. Now my all ports are belongs to VLAN 10. If you want to change your VLAN name, so you can change it. Just type name and you can type IT and O. So like this, you can change your VLAN name. Okay. Now just tell me, do we have reachability from the laptop 1 to 6? Yes. Yes, really. Huh? Now we have two VLANs. This ports I belongs to VLAN 1 and this ports I belongs to VLAN 10. So how can we reach from one network to the second network? You know, we didn't discuss that, right? In this scenario, do we have or not? No, we don't have. Come here and check it. We don't have any reachability because that switch is like that PC is belongs to different network. So that we can't communicate from the one network to the different network, like one broadcast domain to the different broadcast domain. We can't communicate by default. We have some parameter, we'll discuss later. But as of now, we can't. You can see here, if I'm sending the packet from the laptop 1 to laptop 2, so we have. From the laptop 1 to 3, yes, we have. But when I'm trying to reach from the laptop 1 to 4, we don't have. Why? Because both PCR belong to different broadcast domain. Yeah. But if I'm trying to ping from the laptop 4 to 6, so yes, we have. Yeah. Now, I want to change this port number from the VLAN 1 to VLAN 20. I want to create one more VLAN from the third method, some different methods. Exit, interface, range. Just first check how many VLANs we have. So VLAN grid, we have only 1 and 10. Now I want to create a VLAN 20. And in the VLAN 20, we have some port numbers 1, 2, 3. Now I'm feeling cool. Okay. Now in the VLAN 20, like I want to create one VLAN here 20, and I want to make all these ports into the VLAN 20. So F0 by 1, 2, and the 3. Now come to the switch, the SWAR interface. We have only 1 and 10. Interface, range, F0 by 1, 2, 3. Command is switch port access VLAN 20. We don't have that VLAN 20 is going to create automatically. You can see access VLAN does not exist, creating the VLAN 20. Now check. Do so VLAN 3. Now we have VLAN 10, VLAN 20, and the VLAN 20 we have some interface. So like this also we can create our VLAN. Okay. So any doubt? No. And the last, just remove this laptop 3, F0 by 3, okay? And this one is F0 by 4. I'm taking the two routers. This one is F0 by 3, F0 by 0, here F0 by 3. And this one is belongs to F0 by 4. I want to convert this routers as a DHCP server. Enable config. Quickly, I'm going to configure host name DHCP. Let's say VLAN 20. DHCP. Then IP DHCP full name is test network 192.168.1.0.255.255.255.0. Okay. And default route 192.168.1.10. On this interface also we have to configure the IP address. IP address 192.168.1.10 255.255.255.0. Then no support. Okay. we fire these commands. Same command I want to fire in the router 2. Copy here, line. Paste. Just I want to change my host name. Fix it. Host name DHCP VLAN 10. Okay. So now here you can see on the router 2 also we have same IP address .10, and here also we have same IP address .10. Why? Because both are belongs to different networks, so we can assign the IP address. Now come to the laptop 1. Now just tell me if I am receiving if I send the DHCP request from the laptop 1, so we are going to receive the IP address from which router? Router 2 or the router 3?
Router 2.
Let's do one thing. Just change here your default route. Then we can get the exact idea. IP DHCP full H2 default router 192.168.1.100. Address 0/0. IP address 192.168.1.100. Now just tell me again, if I am sending the DHCP request from the laptop 1, so we are receiving the IP address from the router 2 or 3. Why? Because this is my one domain, this is my second domain. Let's check laptop 1, configuration DHCP 1.10. And here laptop 4 1.100. So we can deploy 2 DHCP server in one network, but different broadcast domain. Okay, so like this we can do it. DHCP 1.10, 1.100. Any query, any doubt in this VLAN? How to create it? No? Okay. Do this task. Dividing a network. Okay, so just do this task. If you have any query, just ask me. Okay, I'm done with my today's class. On Monday, we'll discuss about the trunkings and all. And the Tuesday, we'll discuss about the lab. Okay, physical labs. Okay then. Okay, guys, any query, any doubt? Online, guys?
No.
No? Okay, then I'm done with my class.
So,